Aloha! Today I will talk about how we can overcome cherry-picking in research. People frequently cherry-pick evidence to support their preconceived conclusions. In psychology, this behavior is associated with concepts like selective perception and attentional bias, which describe how individuals focus on information that aligns with their beliefs while disregarding conflicting evidence. For instance, some Christians may highlight specific Bible verses that support their theological views while ignoring others that challenge or complicate their perspective. This practice, sometimes referred to as bibliolatry, involves an excessive reverence for the Bible that can result in selectively interpreting Scripture to uphold dogmatic beliefs, often at the expense of a more holistic understanding. This issue is not limited to theology, it extends to all disciplines and subject areas. It could happen in qualitative research, where interpretations are inherently subjective. For example, colleges and universities often collect student evaluations at the end of each course. While quantitative data, such as Likert scale ratings, tend to be less contentious, interpreting open-ended feedback can yield drastically different conclusions depending on the evaluator's perspective. An evaluator who views a faculty member favorably may highlight only the positive comments from the feedback. Conversely, if the evaluator has already decided that the faculty member is underperforming, they might focus on the most negative comments while disregarding positive ones. The good news is that modern technology offers a solution to this problem through text mining, an AI-driven approach to analyzing textual data. Also referred to as text analytics, text mining involves extracting meaningful information from documents by identifying and exploring patterns of interest. It leverages natural language processing, NLP, a subfield of artificial intelligence and computational linguistics, to understand and process human language. By utilizing machine learning algorithms, text mining automates the analysis, reducing reliance on human interpretation and minimizing subjective biases. Within text mining, there is a specific technique called sentiment analysis, also known as opinion mining. This method focuses on identifying and categorizing emotions expressed in textual data. Specifically, sentiment refers to an attitude or judgment based on feelings, such as, "I like using AI." Opinion, on the other hand, is a view or appraisal about a specific matter, such as, "I think AI results might not be accurate." Although these terms have distinct meanings, they are often used interchangeably. Sentiment analysis examines the polarity, positive, negative, or neutral, of sentiments in open-ended responses, enabling researchers to quickly identify conflicting or diverse opinions on the issue being studied. Beyond classifying the type of sentiment, the algorithm assigns a score to reflect the intensity of the emotion, providing an objective measure that helps mitigate the subjectivity of interpreting textual data. Additionally, sentiment analysis is particularly valuable when the sheer volume of documents makes it impractical for humans to review them all, addressing challenges such as fatigue and boredom. In this example, I analyzed an old dataset of student evaluations for a faculty member using sentiment analysis. The software app for this illustration is JMP Pro, developed by SAS Institute. Sentiment scores range from -100 to 100, with scores near 0 indicating neutrality, those closer to 100 reflecting positive sentiment, and those closer to -100 indicating negative sentiment. The results show that the majority of student responses are positive, represented by the orange bar in the histogram. Obviously, the distribution is skewed towards higher scores. In contrast, the blue bar, which accounts for the minority of responses, reflects negative perceptions. This text mining approach is a powerful method to counteract biases such as cherry-picking and selective perception, providing an objective and comprehensive analysis of textual data. However, text mining is not entirely foolproof. Human language is inherently complex and context-dependent, which can sometimes lead to misclassification of text into incorrect categories. For example, in this analysis, terms like bad, problem, non-responsive, and, unfortunately, are flagged as negative perceptions of the class. In reality, when student 17 used the term non-responsive, the learner was not referring to the professor's responsiveness. Instead, the comment was about other students. The student wrote, "Other students in the class can be disrespectful and non-responsive to his questions, but he always tries to engage with the class and encourages discussions." The word bad does appear in student 80's response, but the context reveals that the student is referring to the professor's concern about receiving a bad review, rather than expressing a negative opinion about the class or the professor. The student wrote, "He has nothing to worry about. He provides all of the necessary material and information to be successful in this course. If a student is unsatisfied, it is likely because he or she did not put forth equal effort." Similarly, although student 81 mentioned problem, what the student said is, "Great professor. He shows he really cares about the learning of his students and will go above and beyond to make sure they understand the material. Enables students to use their problem-solving skills to search for answers." Student 101 used the word, "unfortunately," but it was actually referring to the situation rather than expressing a negative sentiment about the professor. Due to the sensitive nature of the information, I cannot disclose the text here. If these errors are corrected, the overall sentiment score of the evaluation would increase even further. Nonetheless, even with an accuracy rate of 90% or 95%, AI-based text analytics is generally more reliable than human subjective interpretation or selective perception. It is important to recognize that feedback data reflects the perceptions of the respondents and does not necessarily represent objective reality. For instance, if a student claims that a faculty member sexually assaulted her, it would be absurd to accept the accusation outright without giving the faculty member the opportunity to present his perspective. Therefore, responsible researchers and evaluators should adopt a triangulation strategy, incorporating multiple data sources and methodologies, to develop a more comprehensive and balanced understanding of the phenomenon being studied. Happy text mining! Thank you for watching.